Hey everyone. So today I'm going to be designing an online auction service. This is a very popular system design question right now. So yeah, gonna try to get through it, and I'm gonna try to keep this within 50 minutes because I want to simulate a real system design interview. So I'm going to try to get through it at the same pace I would if I was actually doing an interview. So yeah, let's just get into it. So design an online auction service. I'm gonna quickly show what the UI should look like, or what I'm thinking the UI will look like, because that will help you kind of figure out what's going on. So probably let's just think it's like some web page like this. Um, Maybe there's a search bar where you could pretty much look for different auctions. Then maybe let's just say that it drops like a bunch of search results here, the different auctions you can get, right? One, two. These are the different auctions. Pretend you go and click on one of them. You should probably get routed to a different screen where you could see more details of an auction, more details of auction, and then maybe like highest bid because people are bidding against it. Highest bid, more details of auction, highest bid, and then maybe you could try to place bid. Right. So you're placing bids and highest bid. Let's see, highest bid should update in real time. Something like this. Yeah, that's kind of what I'm assuming this to be, and you could then place a bid, and yeah, you should see should update in real time. Highest bid, place bid in real time. Maybe you know if it's yours or not. Maybe we'll just say like the person who has the highest bid. I don't know. That's we don't want to really disclose that. So maybe we have an indicator telling you if you have the highest bid or not, because that's also important to know if you won the current bid. Because imagine lots of people are placing bids. But anyways, let's just ignore that for now, and let's just say yeah, maybe we have some green indicator if you have like the highest bid or something like that. Um, yeah, let's see. Cool. So design an online auction service. Well, I said that before the functional requirements even came in. So let's update the design based on the functional requirements. So users should be able to post an item for auction with a starting price and end date. Okay. Users should be able to bid on an item where bids are accepted if they are higher than the current highest bid. Okay, so they're looking at this screen, and maybe we don't care. You should be able to view an auction where the bids are accepted if they are higher than the current. Users should be able to bid on an item where bids are accepted there. Okay, cool. Let's just keep this search screen for now. But we probably won't write the APIs for that. But essentially, we'll have like a different. Let's have a different. Let's have a different screen where pretend in this search screen maybe they have like a plus here where you can create an auction, and then you pretty much have a create auction form. So we have a create auction form with all the details, and then you could submit. So once you submit that, it should get indexed and it should be appearing in the searches. But after you create it, then people can click on it and get to this. So yeah, I think that handles all our functional requirements here. Let's just move on. This is the delivery framework that they're suggesting. What are the non-functional requirements? Write your answer on the whiteboard, then click get feedback. Okay, cool. What are the non-functional requirements? I think let's look at consistent. Let's put a timer. Consistency over the availability. In our case, we probably availability. We definitely want consistency when it comes to placing when it comes to placing bids. We want essentially what's going to happen here is pretend we have a bid and a lot of people are bidding. There's going to be a lot of contention for who has the highest bid, and it's going to, or competition essentially for who has the highest bid. And we just need to make sure that the highest bid, the person who has the highest bid is consistent across everyone. And you don't think you have the highest bid, even though, yeah, we don't lie to anyone telling them they have the highest bid. They should know if they have the highest bid or not, and it should be accurate, because we need to be able to inform them what the highest bid is so they can make decisions. So consistency when it comes to placing bids and showing who the highest bid is. That should be strong, consistent. And showing who the highest bid is. Let's say low latency, probably sub 200 milliseconds, or around less than 300 milliseconds. Let's just say less than 300 milliseconds when it comes to broadcasting the highest bid changes to all people viewing auction. And yeah, it should have strong consistency when it comes to placing bids. Low latency when it has that. It should be pretty resilient when, resilient or durable. We don't want to drop people's bids, especially if they have a winning bid. But durable, we don't want to drop people's bids. Lastly, I mean, they said the scale of 10 million people should be highly scalable. To handle 10 million concurrent users. Cool. Got that off within time. Let's get some feedback. We gotta work on pace. Nice. So we identified all the non-functional requirements. Your answer is well contextualized, showing clear understanding. Okay, what's the sample answer? Strong consistency for bids, fault tolerant, can't drop bids, real-time max bid display on client, scale. Sounds good. Let's move on to the next part. What are the core entities of the system? And we need to spend 2 minutes on that? That's crazy. Okay. Let's think about it. Definitely users. And then once we have a user, let's think about the UI. We need different auctions. So these are the things that they're auctioning for, and then bids. So when we look at the UI, we have the different people and we have the different auctions that we're going to show in this list. These are the different auctions that we show in this list, and when they click on an auction, they should be able to make bids against that auction. I think that's all we literally need there. Users, auctions, and bids. Yeah. Auctions will contain the more details specific to the auctions. We'll be able to search for auctions there and create auctions. And yeah. We'll have like a list of bids for auditing and objects, a bunch of rows in the bids, so we know, yes, kind of for auditing purposes, I guess. Let's get feedback on that now. See if I missed anything. Let's get it. Yeah, I was thinking auction item would be there. Cool. Yeah, they're right. I should probably have item there. But I was thinking that was just part of the auction. API routes. How long do we... Okay, 5 minutes on the API routes. So let's look at the functional requirements and then pretty much build out our API endpoints using that. So yeah. let's do you should be able to post an item for auction with starting price and end date. So let's see, post, and let's say this is we can create auctions, and description. This is a REST. We're doing everything with REST, but as REST APIs. So it's going to return an auction object. But essentially endpoint to create an endpoint to create an auction. User will specify. I mean, yeah. Let's just say we'll have a body. We'll have some headers. The headers will be like some auth token. Headers auth token. We like whatever authentication we want to do, which is sessions, JWTs, whatever. Body. So for the body, let's say they want to specify auction details, item details. We have a starting price, and then we have a end date. So they kind of pass this in the body. We'll create that auction, we return them back that auction, pretty much that auction, so maybe they can display it to the user. But end date, user should be able to bid. Okay, that allows us, that's their first post request. Let's see. We can get auctions, and then we can pass in the auction ID. So what they can do is endpoint to get the details of an auction, right? They can perform a get request, and pretty much they can pass in auction ID in the params, path params, auction ID equals link or ID of the auction if we need to query the database and figure out the highest bid and return all the details. Let's see. Yeah, that'll hit 3. Users should be able to bid on an item. Let's see. Users should be able to bid. Let's post, and then we'll say bid, and I don't know. Bid. We'll say this is like a partial, because we don't need to return everything about the auction, maybe just if they want the bid. So they do a post, auctions, auction and bid, endpoint to post bid. We'll pass in a body here. Body equals, so they're posting an auction for a specific auction ID, and they're doing a bid here, and endpoint to post a bid. I mean, the path param is also the auction ID, and then we'll have a body, which would be maybe amount, whatever their bid is, details about their bid. But essentially, response equals, we'll give a 200 if success, and I mean, we'll always return a 200 because it's not like a user error if they get it wrong, but we'll just return a 200 as in we received your bid. Then we'll say accepted if bid won. But in a case that actually someone beat them to it before they write it, and we'll speak about this later, we'll accepted will be rejected if bid lost. And yeah, these are probably all 200s, and the regular like 400 and 500. 400 if it's malformed, 500 if it's a server error. Same with these. But this one, I think we need to specify our request or what the response is a little bit more. So users should be able to view an item. Okay. Since we hit our 5 minutes, let's just click get feedback. We're racing through this now, but we're trying to get this in within under 45 minutes because this is what you expect out of an interview. So you provided a comprehensive set of API endpoints. The creation, viewing, and building. Okay. Clarify. Why would we need to paginate an auction ID? We're grabbing one specific auction. Post. Place. View. Cool. Looks very similar. High level design. How long do we have here? Okay, we have more time. So how do I specify, however, in general? Okay, how will users be able to post an item for an auction? I'll try to spend at least 5 minutes on this. Okay. So what we're going to do is we're probably gonna we're gonna have our write service separated from our read service, because, or like our live auction service separated from when we're just creating auctions, because creating auctions, because like the servers for handling an auction are going to be very specific, because it's gonna be handling broadcasting and all that stuff to all the different people who joined into the auction. But writing is kind of like a async or something that we do on the side that doesn't really happen that much of people creating auctions. So we don't need to mix that logic in with our more complicated logic, which is like handling an ongoing auction and broadcasting updates to all the clients. So let's just say that we have we have a service for like an auction service, I guess, and a bidding service. Auction service just handles like manages things related to just creating auctions, reading what auctions exist. And then we'll eventually have a bidding service, which will handle like this cutthroat bidding when people are auctioning against an item, right? So let's do client here. So we have a client. The client is going to talk to our service, but we'll probably have an API gateway here because we have a microservice architecture. It needs to be able to route to the different services. So we have a client that's going to talk to the API gateway, and it's going to get routed to the auction service. Let's not draw those boxes to save time, but essentially we'll have a database, and right here I think the database choice here is kind of arbitrary. So I'm gonna just go with a regular, let's just say database, let's just call it database for now. And I think the more interesting parts of the problem are not really with the database choice, but how we're gonna deal with consistency. So, well, the database choice can help with that. So let's just say we have DB, and I think I'll definitely go with something like Postgres for now, just because we need to offer eventual consistency. And I just know of better ways to do that using a regular SQL database. There's ways to do it with a NoSQL database as well. But yeah, I think it's not that important of a decision, so I don't want to stick on it right now, and I'll tell the interview that yeah, we just have a database where we're going to be storing our auctions, right? Yeah, because I think SQL or NoSQL database is going to work here in my final design, and you'll see that at the end. So we have our client, we have an API gateway, we have our auction service, and we have our database. Users will be able to pretty much do the post request to the API gateway, and let's just copy over some of we'll fill in our auctions. So they're gonna create a post request. they're gonna hit this auction in the database. It's gonna have an auction ID, which is a UUID. It's gonna have details about the item. It's going to have pretty much created at timestamp. And what are the other functional requirements? Oh yeah, the highest bid. Let's see what they're posting in. I need to maintain this somewhere. Gonna maintain this on my other screen. So we're gonna need the auction, the UUID. We're gonna have our starting price here. Starting price, which is like a number. And yep, end date as well. Cool. So we're gonna have our auction, a starting price, an item, and the end date. So that will allow us to figure out which auctions are live. Yeah. So cool. Let me just mention that now. So how will users be able to post an item for an auction? So we're gonna have a client that's gonna talk to an API gateway. We have an API gateway there because we're gonna separate the auction service from the bidding service eventually. But pretty much when the API gateway will route them to the auction service, the client will be doing a post request to create the auction. So yeah, pretty much they'll have a form on the front end where they fill out details of the auction, such as the starting price, the specific item that they want to auction, and an end date for the auction. That's all going to be specified in the body of the post request. When we send that post request into the auction service, it will create a row in our database, and we don't really, we're just going to use a simple Postgres database or a SQL database here. I think the decision there is not that important. And yeah, pretty much it's going to create a row in that database. After it's successful, it's going to return back the auction ID to the client and a 200 to tell the client that they successfully created the auction. And yeah, that's kind of the flow of the data. Processing. Get feedback. What's that sample answer? Okay, they got the same thing. User wants to create a post. They use the client to enter details. Oh, I didn't talk about validating. Cool. Yeah, pretty much what I had. How will users be able to place bids on items? I'm gonna do 6 minutes on this. So what are we gonna do is we're gonna have the client. Clients are gonna talk to the API gateway as usual, and we'll have our bidding service. We're gonna have our bidding service. The API gateway is going to route to our bidding service. The bidding service, and we're gonna talk about how to scale this. But what the bidding service is going to do is it's going to pretty much talk to the database for now. So they're going to send a post request. It's going to talk to the database for now and read the current bid or the highest bid for a specific. It's going to read the highest bid for a specific auction. And if their bid is higher, we're going to insert that into the database and return success back to the client. Let's see. Yeah. So let me write bids here. So we have bids. Bids are gonna be stored in our database. So we know, so we have sort of a history for all of our bids. So our bid ID is a UUID. We'll have not just the bid ID, but we'll also have the bid price, which is a number. And yeah, simple things created at. That's that. Okay, let me just look at this quickly. We have a bid, endpoint to post a bid. We pass in the bid ID and we pass in the amount, and yeah, depending on like we'll read the data. Like the most simple naive is to just lock the rows of the auction. Pretty much lock the row of the auction with a transaction. Do a transaction that first locks the row of the auction, and then we'll also update the row of the auction, or we'll update the row. You'll lock the rows of the auction, read the auction to see that, or read the auction, see what the highest bid is, and then if it is the highest bid, or if the current bid is higher than the highest bid, we'll replace that highest bid with ours, and then write a row into the bids, essentially meaning that the bid was successful, and we'll return a success back to the user. Cool. So let's see. Let's just say do this. Create bid. They'll pass in like the auction ID. We're just simplifying this to like some sort of function. Up here we'll do create auction. Okay, let me say that to the AI now and see what they say. So users will be able to create a bid, or will be able to place bids on items pretty much through that post endpoint to create, that I mentioned before, to post an auction, post a bid to a specific auction. So they're gonna have the auction ID because they're gonna have clicked on that specific auction on the UI, so they'll have access to the auction ID. Then they'll be able to post like bids towards that specific auction ID. When they send the post request, it's gonna hit the API gateway. The API gateway is gonna route them to the bidding service. That bidding service is gonna do a couple things. It's going to first read from the database the current highest bid that happens, or the current highest bid right now for the auction, and then after it reads the current highest bid, it's going to see if the current bid is higher than the highest bid. If it is, it's going to replace that, and we should have the highest bid. And then it's also going to write into our bids table. And yeah, if it successfully if it successfully took the highest bid, it's going to send that response a success back to the user. Otherwise, it's going to tell them that their bid got rejected. And yeah, that's kind of the flow. And all of those, like those operations for reading the highest bid and then updating the highest bid if the one that I read is higher, should happen atomically. And we could discuss how we're going to make that work atomically in our deep dive. And the reason we wanted to happen atomically is because what if we have two different people who read down the auction? They think they're the highest, and then they just both write to the database, and then we don't have an accurate one who's the highest. It's a classic, like you have a global counter and both of them read and then they write into it. Okay, wait, let's see what the answer is. The bidding service. The bidding service retrieves the current highest bid, validates the new bid is higher, and stores it. Okay, it then returns. Yeah, that's exactly what it did. Nice. How will users be able to view an auction, including the current highest? How will users be able to view an auction, including the? Let's see. Users will be able to view an auction, including the highest bid. Draw a diagram. I think the bidding service will be able to view an auction, including the current highest bid. To keep this simple, it might seem more complicated because we have it might seem complicated because I'm going to add something else, but I think the best way to do this is have servers that are specifically, whose job is to specifically update the clients of a specific auction. So let's just call this real-time servers. And yeah, these real-time servers, there's gonna be a bunch of them, but essentially all of these clients, the real-time server, clients, they're going to connect with a real-time server through the API gateway. It's essentially going to allow them to connect to one of the real-time servers, and the real-time server is going to push them updates on the current highest bid. So what we're going to do is, oh wait, that's probably complicated. Let's see. Let's just say unless we need to specify this in the deep dive, because what we can do is clients can long poll the auction service and figure out what the highest bid is, because we're storing that on the auction service right here. So, oh yeah, we can store that here, highest bid. And the reason we want to store it on the auction is because we don't want to query all of the different bids in order to figure out what the highest is. That's going to be long if there's a lot of bids. So what they can do is, one initial approach is they can long poll. But then they'll be long polling like crazy if we have 10 million people. So I think maybe what we can do instead is, yeah, I think what I'll do before is we'll have a real-time service, whose goal is to communicate the highest bids back to the clients using SSE, or service sent events. So we'll say real-time service will use SSE to update clients. But how do we know when to update them? So we could follow like a pub sub model. So we can essentially have a queue. So what the queue does is, the real time, as bids come in, pretty much as bids are successful, it's going to put them in the queue, and these real time services are consuming from that queue. Our bidding service is consuming from that queue, or the real-time service are consuming for that queue. And essentially what they do is, different real-time services have different access to different clients, or we could break it down by specific auctions. But at a high level, and we could probably explain this later, as biddings are accepted, we put it in a queue, and these consumers will pull from the queue and then notify the clients if there's an update ready for them. So there's like a notification queue right there, and then the real-time service job is to notify all of the clients when there's a new bid that's happening. This adds a little bit of latency, but if we have a bunch of people spamming the auction service in order to get the data, like it would happen more. It adds a bit of latency, but the only way to reduce that is if we had the client spamming the auction service, and that's also really bad. So I think, yeah, we could do something like this for now. Wow, that was long-winded. Let's see. How will users be able to view an auction, including the current highest bid? So in order to view an auction, including the current highest bid, they're going to hit the API gateway. And when they hit the API gateway, they're going to hit the auction service, and the auction service is going to query the database. So they're going to hit that GET request with the specific auction ID. They're going to use the UI to find the auction they're looking for. And when they click in the UI and load that specific auction, we have access to a specific auction ID. And yeah, it'll load in all the details, and all the details of that auction, including the highest bid, are going to be in the auction table. And pretty much while they're in this view, they're going to create a connection with one of the real-time services. And one of the real-time services is going to have a server side, or is going to send server-side events as the highest bid gets updated, so they don't have to long poll for that. That's kind of my and that's kind of my solution. I'll dig into how these real-time service are going to know when to update clients. That's a separate deep dive that maybe we can get into. Nice. Oh, nice. Okay, wait. We can continue pull this endpoint. I said that originally, but this is not good enough. But as a start, I'll go into more detail when discussing the non-functional. Okay, cool. Yeah, he's just polling. Next question. How can we ensure strong consistency for bids? Now we're getting into the meat of it, which is the deep dives. So how can we ensure strong consistency for bids? Let's see. Let me think. So probably, since we're using a SQL database like Postgres, what we can do is when a bid comes in, it will pretty much lock the row for the specific auction to see what the highest bid is. And that it'll do this all within a transaction. It'll lock the row of the specific auction. It'll see if my bid is higher than it. Then it'll write to that auction if it's higher than it. And then write to the bids one as well. After that, it'll asynchronously up or push that there was a successful bid into the queue. So, one sec. Let me just make sure my AirPods are dying. Input. Okay. So yeah, that will kind of ensure strong consistency because we're locking, but it's pessimistic locking, and we could do optimistic locking as well. But if there's a lot of contention, pessimistic locking might just be better. But I think actually optimistic locking, if we don't have to lock them at all and we could find a way to do that, we could do that. And I could explain what pessimistic and optimistic locking are, but I think in an interview, they would kind of know that already. So if you want to talk about theory, we could deep dive into it. But we can just say at a high level, we're going to use pessimistic locking or optimistic locking in order to on the auctions table. And I'll describe that as I talk to this AI right now. So how can we ensure strong consistency for bids? So the problem with consistency here is that essentially we need to read the highest bid, or different clients will, or different people will read the highest bid. Or let me take a step back. The issue with consistency here is that multiple people could be trying to update the highest bid, right? And the only way that they'll update the highest bid is if their current bid is higher than the current highest bid. So pretend we have two clients that independently read the highest bid. One client has a higher bid, or client one has a higher bid than client two, but they both have a higher bid than the current highest bid. So if they both read it independently, then go both write to it. It's pretty much the last person to write to it will have the highest bid, and not the person who has the highest bid between the two, right? So reading and then writing to the highest bid should be done atomically. So the one way we can ensure strong consistency is to actually do it within a transaction and lock those specific rows, or not the specific rows, but specifically lock the auction table, or the not the whole table, but the specific row for that auction, so that only one person could read the highest bid and then write to the highest bid, and the other person has to wait. So whoever wins the lock will read the highest bid and then write, and if theirs is higher, they'll update that, and then somebody will go next. So it'll pretty much serialize that, so someone goes one at a time, and yeah, that's one way to do it. But yeah, holding locks, that's more pessimistic locking. We could also do it using optimistic locking, But that's one way that we can ensure consistency for bids is just locking that row. And since we're only using one row, it's easy to implement an optimistic locking for this by pretty much you could write like a SQL command where you only write to the row if the highest bid is equal to what you initially read. So yeah, either optimistic or pessimistic, but for now let's just say I'm going to use pessimistic locking for this. I hope, yeah, nice. It's a good question. Where am I at? 40 minutes? Okay. Three more deep dives. Okay, they're talking about optimistic concurrency control. Okay, let's just move on to the next one. How can we ensure the system is fault tolerant and durable so that no bids are lost, even in the cases of failures? Yeah, let's see. This is a good question. Like, I want to introduce a queue here. I want to introduce a queue here for the bids as well. This is our notification queue. These are different queues. So we could have a separate queue to buffer API gateway, the bidding service. We can kind of decouple bids. So we can have bidding, the service, pretty much. Just go with this. We can have a bidding service, and the bidding service kind of writes to this bidding queue. So we don't drop if there's like a high. So what the bidding service does is all it does is write bids into this bidding queue, and then we have bidding consumers that will actually do the work of do the work that is more likely to fail, which is like now the bidding queue is actually consistent, or actually the bidding queue will not drop anything. It adds a bit of latency, but essentially when you place a bid, you're placed in the bidding queue, and bidding consumers will do the work that is more likely to fail, which is like figure out if that bid is good enough or is going to be accepted or rejected. So that's kind of how it do that, and then this would eventually this will eventually write to our notification queue, something like this. And I'll explain it more talking to AI. So how can we ensure that the system is fault tolerant? So the way we can ensure no bids are lost, because there can be big surges for bids, is that we can have the bidding service whose main job is to just write into a bidding queue. So when you create a bid, it will essentially maybe write to the bidding service or the database that you want to make that bid, and essentially also write it to the bidding queue. Then we have bidding consumers that can scale horizontally, but we want to separate adding to the queue with the logic of actually seeing if a bid is going to be successful or not, because we want because essentially the logic for if a bid is going to fail or be accepted or not is more susceptible to failures. So we want to like have that separate from making, or we want to make that logic separate from making our bidding durable, essentially. So pretty much when they post a bid, that gets put in the bidding queue. So that logic is less likely to fail, and we could like store it fast. And now the queue is very durable, and we won't drop their bids. And now we could just consume bids on the first come first serve as they get put in the bidding queue. and essentially we can like try those different bids using the bidding consumer and retry on failures there. But if something completely fails, we don't lose that bid. That's kind of the logic that I'm thinking. So it adds a bit of latency because we have an extra queue here that we're adding, but it just makes sure that when we get someone's bid, we store it away safely, and yeah, we can just keep retrying on this queue. Let's see. Nice, let's go. How are they doing it? Okay, they did the same thing. Cool, 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 cool. How can we ensure the system displays the current highest bid in real time? Oh, should I mention that already? While maintaining how can we scale the database to handle 50K concurrent writes and 50 terabytes of data a year? Okay, I think the more interesting part right here, and since we're at 46 minutes, is how are we going to display the highest bid in real time to all 1 million users? Um, and then we could, yeah, I think that will end it here, and that kind of hit the 45 minutes. But let's see, how can we ensure that the system displays the current? So I mentioned that here. So how are we going to have this real-time services? So the real-time services will probably have SSC connections for, let's just say they're going to have different auction IDs. Different servers will have different auction IDs, and will be SSC1, like the different connections to the different SSCs. And we'll probably break the notification queues by their, we'll have different topics or different queue. Yeah, we'll have different topics or queues based on topics for each auction ID, right? Basically, clients will connect with a real-time service and tell that real-time service which auction which auction they want to subscribe to, and then pretty much then that server will subscribe to the topic as well. So they'll get pushed changes to, or they'll get pushed updates of that topic, and then like they'll store in memory the auction ID and which clients want that, and then they'll send updates to them right away. So yeah, I'll just explain that to the AI because it'll be better, and then yeah, we'll be able to end the interview here and see where it goes. So how do we ensure the system displays the current highest bid in real time to all 100 million users? So what we can do is we can have an API gateway, or sorry, we can have real-time services where the real-time services job is to notify clients via SSE or server sent events when specific auctions, when there's a new highest bid. So essentially what's going to happen is clients will figure out, we'll connect to a server and then tell the server, one of the real-time servers, what auction they're going to, which auction they want to be notified for, and then that server is going to store an entry of the auction ID, and say for this auction ID we need to notify these servers or these clients. Essentially, it's going to be a list of clients that they have to notify, and yeah, they're going to store that in memory, and then also the server is going to subscribe to the topic for that specific auction ID, and then the bidding consumers, as people place bids and win the highest bid, it's going to post updates to that topic, and then the real-time service is automatically going to get updates to that auction, because, or the ones that are subscribed to a topic are going to automatically receive updates because they're subscribed to those topics, and then it's going to, once it gets updates for a specific auction that it's subscribed to, it's going to loop through all of the connections that it has for that specific auction ID and notify that client that something has changed, and that's how we're going to be updating all of them in real time. Yeah, that's kind of what I'm going to do there. And cool, we're going to save it for 10 minutes of or like outros, me asking questions about the company and stuff like that. That's kind of how it works. Aced. This is the first one I actually aced. Let's go. They have their own one. Cool. That's how I'm gonna solve this question. Let me know if you have any feedback. Let me know if it's a strong hire, no hire, weak hire, strong no hire, whatever it is. I'll see y'all in the next video. That was designing an online auction system. I missed out on one part, but we're already out of time and we hit at least a few deep dives. So I'll see y'all in the next video.